about 20 people. Thanks for coming, everybody. We have a very diverse crowd. So it's been a long time since we did the last meetup. This is intended to be a very technical meetup. So Blockdevs Asia. I'll give a quick background here. So Blockdevs Asia is a non-profit that we started in 2017. And the purpose of this is basically, I started together with Chris, who is not here sadly today, because I like to talk to other devs, or we like to talk to other devs about code and exchange ideas and learn from each other. And so we just started meeting up. First in QBO and eventually other places, blockchain space, mostly Makati. And in 2018 and 2019, we pretty much had a meetup every month, and we even had the hackathon each year. The second hackathon had 100 contestants. So it was a big event. 2020 was the big year of COVID, so we did, I think, 1 or 2 in-person meetups, and that's when we transitioned to virtual. And so we did virtual meetups in 2020, 2021 as well, 2022. I think, I was just talking to Gabriel here. He also likes, and I think many of you, it is nice to have physical meetups, to sit with people in one room and just talk to each other. And I was telling him, I like, when I'm doing a meetup, I like to look at the audience and get an idea if they're getting me, if they're following along. And if you do a virtual meetup, you have no clue what others are doing. If the camera's off, all you know, they're playing a game. So I like the focused engagement like this. So we took a break in 2022, and now we're back. It's for the first time it's here. This is our office. Oostenvoort is our blockchain and cloud development company. We have also some people from Oostenvoort here right now. It's the first time here, so I'm super thankful that you were able to find it. We intend to have the technical meetups right here, because this is our office. We have everything. We have internet, we have all the infrastructure. We are actually recording this as well, so am I in the camera? I walked outside the camera, didn't I? So we're actually recording this, we're putting this up on a stream, so this is also going up on YouTube. So why Blockdevs? Well, organize and engage blockchain developers in the Philippines. Networking, representation, and education. So we're just getting started. So who are we? Actually, the board right now is not complete. I'm here, that's me. I'm not sure if Raf is coming. Chris and Tracy were unable to be here, but Mike is sitting up there. He is our community manager. And Mike is also the manager of Meetup, which is one of the sponsors. And the next meetup is not technical, it's more about ecosystem, and that will be at Mike's place in Makati. So, but Mike can maybe say something about that at the end. This is before COVID. We need a new picture. So, what's the plan before we start? So, organizationally, this year, every odd month, we'd like to do a deeply technical meetup like this one. So, March 18th, then May, July, September, November, and then ecosystem non-technical meetups in April, June, August, October, and December. And if everything goes well, it would be really nice to have a hackathon again. But let's see how things go. So, we need sponsors. At this point, Oostenvoort is sponsoring it. I think we also need some help eventually with community management. Our chat channels are kind of quiet right now, so we need to warm everything up again. So, all right. I will flash this one at the end again. So, that's us. Now, for the real start, are there any questions so far? Any questions? No? Okay. All right. So the title of the meetup is Next Generation Tooling. So why did I give the title? I have to look at it now like this. So if you're developing on Ethereum, there are different things that you're doing. There's front end, the browser. Everybody has used the dApp before, so that is the browser code. Backends, this is where the transactions usually get triggered. Smart contracts, the actual code, and simulation and testing. And as the projects get more complex, you need to do a lot of simulation and testing, because one tiny mistake can cost you millions if you get rolled. Ostenford, we have actually had a major project in the last 2 years, and at the peak there was $100 million in it. So yeah, you can imagine that we had our share of being afraid of getting rolled. But so far, everything went well. Also thanks to auditing and all kinds of other measures that we did to prevent it. So, quick thing about front end. So right now front end, if you code Web3, most of the time it's React. Vue.js, I was a fan of Vue for a few years, but now it's going away. Everything is React. So they did a really great job there. And then in React, there's a lot of SDKs. So there's a lot of code that you can use from other vendors. Quality, Morales, Alchemy, Ethers.js. So yeah, feel free. We can also share the deck later. You can copy the links if you want to. And this is all for the web applications. And in theory, if you have a very simple Web3 application that only does very simple NFT stuff, this is all you need to work with blockchain. But you cannot build like a bank or something. You can build simple NFTs, but you cannot make a trading platform, for instance. So that's the front end. Back end, when we started out in 2017, there was Infura. There was one backend service where you could send your transactions to, and they would process them on the blockchain. Because if you do it yourself, you have to run a node, you have to run a server that talks to the blockchain, which is very expensive. I think we ran, I'm looking at Lee, we ran a BSC node, a Binance Smart Chain node ourselves, because we wanted something fast, and we were paying at some point $1,000 per month. Right? So at that point it stopped being fun, and we gave up, and we just started using one of those. I think we started using Infura, and we paid them $500 a month. Still, you don't have to manage it yourself. It cannot get hacked as easy. So, backend development. There's the existing APIs. What we're also doing is writing custom backends if we need very special stuff. Mostly happens in TypeScript, serverless on AWS or in Node-Express. And the libraries that we use is very often Ethers.js. So everything you need to create the transaction, to sign the transaction, to send the transaction to the blockchain is in there. Or, I don't know if anyone says, hey, you forgot one. No. Moving on. Smart contracts. So smart contracts are the ones, is the code that is deployed to the blockchain itself. In our case, the Ethereum blockchain. Smart contract code is executed by all the nodes that make up, all the servers that make up the blockchain together. So that makes it very safe, because you cannot have one server run your contract code and then give themselves a little bit more money than another, or mess with it. They cannot, because thousands of other nodes are running that code as well, and if they find out that one is cheating, they get punished. They lose a lot of money. That's it. That's in a nutshell how it works. So if you want to code smart contracts, an example of a smart contract is an ERC20 or an ERC721 contract. ERC721 is an NFT. An ERC20 is any token on the Ethereum network. But they're simply code. Nothing magical about it. So if you want to code on it, you can use Remix. It's an online editor. You can type up your contracts, you can compile them, you can actually deploy them to the blockchain, and you can use them in there. So, if you have a small project, don't bother, just go with Remix, and it's fine. Now, the OG Truffle, I looked after 3 years, they're still there, but I don't know, I moved on to Hardhat 2 or 3 years ago, never looked back. So Hardhat is a TypeScript-based library that almost everybody's using. I think KB, you had like stats, right? Hardhat was 90%, 70% high, right? And then Foundry, Foundry is a new one. As a company, we also like Rust a lot. So we have been doing everything TypeScript, getting increasingly frustrated with how slow it is and how, imperfect the language is. So we are transitioning to Rust, and so are the big players in the Ethereum ecosystem as well. So people behind Aave and some other big platforms started Foundry, and today we'll actually go more in depth on that toolset. So Foundry is a system that you can use to develop smart contracts and test them. I'm adding ChatGPT. It's a bit of a thing right now. I got a link to a Twitter that I didn't check yet. I should have checked it. And then someone supposedly put the source code of a smart contract into ChatGPT with the question to give all the security holes. And ChatGPT gave all the exploitable holes in the contract. So, it looks like slowly this is not a joke anymore. ChatGPT is starting to generate useful output for coders and for security researchers. So, still don't know what to think about it. Like all of you probably. Next, and this is for today's technical section. Simulation testing, Remix does a lot of that as well, because Remix does everything. There's also Tenderly, that is an online application where you can point to your contract, give the source code, and then they will tell you everything that happens on it. So it's a very easy way to see, this person called this function in your contract and this came out. So it's for debugging a live contract, basically. You can also see the line of the source code that went wrong. Very useful. Hardhat network is for on your own computer. Foundry and Anvil is also on your own computer. Finally, this is something that we develop in-house. That Mike will show us. So, today's topic. So this is it's a bit of a gamble, we don't know who's the audience going to be. In the meetup.com RSVPs, we saw about 6 to 7 people, experienced blockchain developers. I do hope they're coming in at 3 p.m. I really hope they're not at the wrong building, or you never know, that they were sent the wrong way by Waze. As it looks like now, we're not going too much in depth, but still, I think everybody can learn something. So, Kim Bermudez and Michael Francisco will, after me, show you some code that they have done. Kim will talk about Hardhat and Foundry. So, we have been doing blockchain development now for, since 2017, 6 years. And the last 2-3 years under very high pressure for big customers. So Hardhead Foundry, these are the tools as we are using them right now, or actually we're improving them, we're moving to Rust, we're moving to Foundry. So these are our newest insights. So I think it's interesting. Mike? Well, Mike can give another explanation of the fork server, but in a nutshell, our practical problem is we build very complex systems, and if something goes wrong, it's very expensive, and we don't know. Sometimes we get a call in the middle of the night, and there's a user that says, I was supposed to get this, but I only got this. And then everybody's scared. Oh no, the system is broken, the math is wrong, there's something terribly wrong, and now millions of dollars are, moving the wrong direction. So, and this is on chain. This is on the Ethereum main chain. If you want to experiment, you can't experiment. So if you mess it up, you mess up millions of dollars. So what we really needed badly is a way to say, okay, this is the situation now on the mainnet, Ethereum mainnet. We want to simulate. From this point forward, we want to simulate. What if I do this? What if we do that? Oh, we think we can do a fix. What if we apply the fix and then do that? But without actually doing it, because that's super risky. So a fork server is basically, a fork is copy. So we make a local copy of the Ethereum state of the blockchain, and then we act on it as if it's real. Very useful and very fast compared to messing around with a live situation. So I think after this, KB can take over, but I'm not sure if anyone has a question so far. Any words? It's okay to be honest about it. If are there any words where you're like, I have no idea what this means. So we're all here to learn.
So while I'm assuming the tooling is all Ethereum specific.
Yes.
All the concepts can be used to all blockchain platforms, right?
Yes. Yeah, but this tooling is very specific to Ethereum. So for instance, if you're talking about Solana or other blockchains, it is not compatible with this at all. It's something else. But actually, this is Ethereum in the broadest sense of the word. It's actually about EVMs, the Ethereum virtual machine, and the Ethereum mainnet uses the EVM, but Binance Smart Chain also uses the EVM. So there's a lot of, and Polygon, you name it, there are actually a lot of different blockchains that are using the EVM. So we are, as a company, we are ready to deploy our product on 10, 20 different EVM-based blockchains, and these tools work with all those blockchains, but not a different technology like Solana. Anyone else? Okay, so KB, Kim, will take over. Yeah, you ready? And then, KB will actually show us the tools. Feel free to ask questions. So if, I'm sure you will see a lot of code, but feel free to ask him questions. So if you're like, no, why are you doing that, or what is that? Just ask. We're here to learn. Right.
Okay, so good afternoon, everyone. In light of the main topic for today, it is the next generation tooling for Ethereum smart contracts. I'm here to present to you our tools, which is currently Hard Hard Hat Foundry, the hybrid approach. Okay, so just a quick introduction about me. I'm Kim Bermudez, or KB for short, and I've been a software developer for 4 years now, and more than two of those is on the blockchain space. Okay, so let's start with a quick introduction regarding our main tools. So as you've heard, Caspar already made an introduction. Okay, but let's start with Hard Hat. So Hard Hat is built in JavaScript, so it's very flexible since you have the power of the npm in order to use the plugins. So that's why I think that's the reason why it became the top downloadable hard hat. I mean Ethereum environment. So as you can see here on the latest Solidity developer survey, as you can see, Hard Hat is the top choice here, and Remix being an easy IDE to get access to. Hard Foundry, the one that is using Rust, and the old first, which is the Truffle. So now let's talk about Foundry. So Foundry is also an Ethereum environment tool, which is built in Rust, and these are the tools that it gives. So like the Foundry of the literal sense, we have these items. First is the Forge. It is their test tool. So most of the reason why we're going for Foundry is because of their test tool, the Forge. Then another is Cast. It's just a command line interface in which you can access the Ethereum blockchain. Again, the Anvil, it's a local node that it's like you have your Ethereum node or the Ethereum blockchain in your local device or your local computer. Yeah, and Chisel is just a REPL for calling the Ethereum blockchain. Okay, so before we go to our highlights for every project development phase, do you have any questions? All right, so I'll proceed with the contract development. So for the contract development, we've used Hard Hat for the majority of our contracts, and they're just very different. There's just a few differences regarding Hard Hat and Foundry. So as you can see, again, Hard Hat is built in JavaScript. So if you have written JavaScript, you could see the similarity here. So it's using npm and it's storing its dependencies in node modules. Okay, so this is a sample contract that's calling these dependencies. Okay, so for Forge, it's also the same. You can see that it's like the same here, the importing, the contract. But the good thing about Forge is you could have some remappings. It's just a nice tool in order to shortcut your imports. So if, for example, Open Zeppelin has a lot of contracts, and if you want to choose a folder that's too deep, you could use remappings in order to just go straight to the directory. Okay. All right, so the big reason why we're using Forge again is the speed that it has. So from the creator of Foundry, he gave this benchmark regarding two of the mostly used contracts. For DEXs, it's Uniswap. Then for the contract standards, it's Open Zeppelin. So of course, this is from the creator, so I had to check it myself if it's valid, if it's true. And yeah, I went in and looked for the Uniswap contracts, and as you can see, it's close to what is presented earlier. So hard hat or Forge is actually really faster than hard hat on this compilation. All right, so before I continue with debugging and testing, do you have any questions? Okay, so here is the majority of the difference where you're gonna see, because you'll see that hard hat, again, since it's built in JavaScript, testing is also done in JavaScript. And in order to bridge that gap where you're working with JavaScript and then you want to test smart contracts, there are a few libraries that you need to look into. Here, ethers. So there's the vanilla ethers that is being used in order to interact with the blockchain and the smart contracts. And this flavor of ethers, as you can see, it's from Hard Hat. So this ethers allows you to have a more helper functions in order to properly manipulate the state. Okay, for TypeScript users, any TypeScript users? Oh, okay. So yeah, so for TypeScript, so the promise or the main reason why we're using TypeScript is actually the types that we could put. And with contracts, you need to make sure that you're calling the correct contract, you're giving the right parameters. If you compile your contract, you need to be aware that there are changes. So typechain allows you to have that power. Then Chai, which is part of Mocha, it's the assertion library. So you may already see that there's a lot of these plugins that are being made in order just to have that experience of really testing smart contracts. So what if we could just go straight to the smart contract and not really much care on what the surroundings are? So good thing we have Forge, which is, just as it says, it's testing using Solidity. So here it is a sample test with some additional functionality given by the cheat codes that Forge gives. So for example, earlier you have Chai in order to check for expectations, assertions. Now we have it here on this interface that we could access from this address. Also, we have prank. So we could impersonate users to use them in order before calling functions. So we use prank. So I'll have a quick demo later regarding most of these functions. And of course, since this is straight Solidity, there's no async await that you need to look into or you need to take care of. So this is a good straight to the Solidity files. All right. So next, as you can see here, these are the tests earlier. So this is about 2 seconds for hard hat, and for Foundry, it's a quarter of a second. Yeah, the hard hat, you're writing TypeScript. You're writing TypeScript and then you're using plugins in order for you to call the smart contracts. So it's not really that similar in that regard. Yeah.
But if you use TypeScript, you can convert it to JavaScript.
Yeah. If behind the scenes, it compiles the JavaScript. But yeah. Okay. Any additional questions? Okay. So you see the performance, right? So you see that testing is faster than Forge. So why don't we just use Forge for all of our tests, you may ask. Though there are different kinds of testing. So maybe unit testing, we could go for Forge, but there are other parts of testing as well. Currently, we need to do integration testing and end-to-end testing. So for that matter, we still need to use hard hat. So this is the first reason why we have the hybrid approach that I said earlier. So for integration testing, you can see that this is the standard hard hat deployment of contracts. And then you can see here, so IPFS, it's like a file storage that is available on the internet. And if we want to have that in our test suite, we need to use hard hat. So currently, well, if we have Rust services, we could switch to those. But as of now, we're going with hard hat on this, also on end-to-end testing. All right, so the final stage of the contract development is the deployment. So currently, our deployment is heavily using hard hat since, as Caspar has said, our contracts increases in complexity. There's a lot of money on the line, and for now, only hard hat and Truffle has the safe validation for upgrading contracts. Okay, so let's have a live demo with Forge. All right. Okay, so this is the standard Solidity file. As you can see, we are importing contracts here. So this is the cheat code that I said earlier. So because of this, we are able to manipulate in a greater degree regarding the state of the blockchain, impersonating users and whatnot. So here we have a mock ERC. As you can see here, let's create a mock ERC contract. Okay, so here we extend test is from here. So this means that we could use the functions of test. Okay, so as you can see, there are two functions here, setup and a test function. So we could do a quick Forge test to check. Okay, you can see it's passing since there's no assertions yet. So function is passing. Okay, now let's declare two addresses that will be used in our test. Okay, so let's go for address. Let's create a deployer, which is an address. Let's go for this. For the purposes of this test, I'll just create some addresses. Okay, so deployer, and let's say let's go for 11. Okay, let's check the addresses of these people. So address deployer and Alice. Let's check. Okay, so as you can see, the logging is not seen because we need to increase the verbosity. So if we do this, now we could see all the logs. So that double V will show the logs. Okay, so we can see that we already have two addresses here. So let's create the instance of let's deploy the mock ERC. Okay, so let's create a declare it here, mock ERC, okay. Then I'll introduce the cheat code earlier, vm.prank. So let's be the deployer. So this just means that the next function will be called by deployer. So we're impersonating the address of the deployer. So this is good, for example, if you want to test, for example, there's an asset that there's an address that you want to use in order to facilitate a test. So you could directly do this. Okay, so let's now deploy the contract. So it's C equals U. All right. So as you can see, it's like the initialization of an object or an instance. All right. So if we check if there's an address, let's check the address of the contract. Okay, so this is the address of our ERC. So as you can see, we could actually let this to compile itself on change, since as you can see it's quite fast. So let's do that. So okay, now it's compiling while I change the contract. Okay, so let's give them some ERC native Ethereum. Okay, vm.deal deployer and for Alice. Okay, so of course let's add the amount. how much Ethereum are we going to give them? So let's just give them 1 Ethereum. Okay, so it's not failing. Let's check if we have the native. So the next cheat code is assert equal. So let's check for the balance of the deployer if it has the Ethereum deployer that balance. Okay. So we're checking it if it has 1 E. Okay, still passing. Now let's check for Alice. Okay, so as you can see, both have balance of 1 E. So let's increase the test. Let's create another one. Let's see if we could send mock ERC from the deployer to Alice. Send token. Okay, so again, we'll use the deployer. Oops, not that. Okay, now we're going to call the transfer function. Transfer. We're going to transfer to Alice. How much? Let's just go for 5,000. Okay. Now we're going to check if Alice will receive the 5,000 mock ERC. Assert equals, so work dot balance of Alice. Okay. Oops. We need to check it with what value? 5,000. Okay. So as you can see here, it's asserting that Alice has 5,000 mock ERC. Okay. So next, we're going to introduce another cheat code. So this is very essential. For example, if you're running a lot of setup code and you want to reuse the state. So there's this thing we call snapshot, in which you could pin a block and you can return to that block after you've done functions and you want to revert or reset. Okay, so function test snapshot. So let's just get a copy of this and see if this will fail later. Okay, okay, it still works. Now let's have a snapshot. So we're going to store the snapshot ID here. Okay, so now we have a snapshot ID here. We're going to revert to this snapshot ID. Okay, vm.revert to snapshot. Okay, as you can see, it's having an error now because we went back to the moment where Alice still doesn't have the mock ERC, which is on this time. So now it checks that this is not satisfied. So now let's put 0. See, now it works because currently Alice has 0 mock ERC. Okay, so to make it quick, let's reduce the typing. I'll just paste the last one and I'll explain what this is. Alright, so let's see. Okay, so as you can see, it took some time, 3 seconds here from the others, which is just 1.59 milliseconds. So what's happening here is we're introducing forking. So since when you test, sometimes you want to call live contracts, and in order for you to do that, you need to fork the mainnet. It's usually the mainnet, because currently the tests we did here, we're working on a clean server. So it has no idea what USDC is here. So if I remove this, okay, let's just remove this, and if I ask what the USDC dot symbol is, so it will revert, so because it's not aware what USDC is, so it's not deployed on this machine. That's why we're going to go and create a fork here, which is the mainnet fork, and we're going to select that, and we're going to pin the block. So for example, let's put the symbol again, USDC dot symbol. Okay, so there. So you can see it understands that there's a USDC now. But if we do remove this, it will not work yet. Okay. So another cheat code that it has is this deal one. There's no VM here. So what this does is any ERC20 token, you could use it to fund an address. Okay, so example here, as you can see, we just comment the other parts. So in this line, we're giving USDC to Alice, equivalent of 100 USDC. Then by using the deployer, which is deployer, I think oh yeah, we're using Alice to transfer 50 to the deployer. So them having 50 each, so this one is working. So it's asserting that it is equal. Okay, so lastly. Okay. All right, so regarding these tests, it is advisable to, as long as you can, create mocks in order to enjoy the fast testing that Foundry gives. So as long as you don't need to talk to a live contract, so you could work and just go with the contracts that you have, especially if you're focusing on the business logic and you don't care much about the other parts. Okay, so all right, so that's the end of the live coding session. So do you have any questions? Yes.
I was just wondering, aside from speed, compiling speed, and the cheat codes, what are other benefits to using Foundry over using hard hat?
Well, if you're using hard hat, again, you need the plugins earlier. If you're using JavaScript, you need the ethers, you need the chai, you need to have a context switch every time you need to update your test, to update your contract. So that's the main reason, I think, why it's better on working with the Forge, especially if it's unit testing. So I would recommend that we go for Forge. So for the others, for integration, we have no choice. We need to use hard hat since we're talking to the off-chain services. So yeah.
So I think what you can emphasize, so we had a full test suite for our latest project, right, that we worked on.
Mm-hmm.
And those tests took 5 minutes to run.
Yeah. Mm-hmm.
But now you have tests done in 40. How long do they take?
Yeah, I think below 20 seconds.
Yeah, so
Instead of 5 minutes,
Yeah.
300 seconds, it's now 20 seconds.
Yeah, because we're working on a lot of tokens there, and it's going back and forth with JavaScript and the smart contract, and we're checking if it worked, and then so those steps could add up, especially if you're working with complex contracts under complex contract tokens.
So the nice thing is that everything happens in Solidity here.
Yeah.
There's no back and forth between JavaScript, Solidity, constantly. So that makes it nice.
Yeah, And also, the big thing here is you see this deal, you're being given USDC already because back when we're using JavaScript or TypeScript, we're looking for a whale in order to impersonate and then fund ourselves. And sometimes it's throwing errors because sometimes the whale moved its account. So with that is also another mental load that you need to think about. So good thing here we could have this cheat codes in order for us to give us ERCs.
Do you already have existing RAS codes for those similar codes?
Actually, so I mentioned Rust.
Yeah.
Actually, Foundry is written in Rust.
In RAS.
And these tests don't involve any Rust. So developers only have to know Solidity to use this test framework. That's a nice thing. Yeah, there's advanced things we are doing with Rust, but this is actually, they don't need to know.
So it's only good for Solidity.
Yeah. Yeah, but since Solidity is also the most risky and expensive part of development, this is a big win already.
So Solidity is only for smart contracts.
Yes.
Yes.
Or testing. No.
Okay, anything else? Questions? Okay, so all right, let's continue with my final thoughts regarding this hybrid approach. So for contract development, we could either go for hard hat or forge, or there's not much difference between the two, since we're dealing with Solidity and it doesn't care which environment you code it on. So for testing, this is where we need to go for the hybrid approach. For unit testing, we need to go for Forge. As you can see, as you saw earlier, that we could code in Solidity if we want to focus on the smart contracts. And integration testing, since our services are written in JavaScript currently, so in order to interact with them, to add them to our test suite, we still need to use hard hat. So for our contract development, I've tried porting it to Foundry, since Foundry also has Ethers RS, which is earlier the Ethers JS that could help you from deploying. But currently Open Zeppelin, the industry standard plugin, doesn't still support that on Foundry. Now, as long as that is the story, we're going to have the hybrid approach. So only time will tell if we will be porting more of our tools to Foundry or Rust. But yeah, that's the current one.
One final question is, are there any design patterns existing in Solidity? Like Microsoft and other software companies have implemented VC, PPT, and that kind of thing? For Solidity, are there any design patterns?
Yeah, for Solidity, the patterns that I saw is, again, there's OOP, there's inheritance, you can extend contracts, and then there's also this kind of like MVC, because there's this implementation contract that has the data, the logic, and then there's like the model in which the database data or the data that the contract has is residing in there. So it's kind of the MVC approach. And there's another contract, it's like the controller. It's checking if you're correctly using both contracts. So it's like controlling the flow if you call a function. So there's MVC there, there's also inheritance. And interfaces is also there. You could create abstract contracts. So it's like the abstract class from the OOP field. Any questions? Okay, so that ends my presentation. So thank you, and please enjoy the rest of the meetup.
Next up, Mike.
Good. Hindi na ako lalagay. Ha? Okay na to. Okay. Lagay ito recording to. Okay. Okay. Afternoon, everyone. How's everyone doing? You guys need more energy. There's coffee there by the window. Marian, please give them some coffee. Has everyone eaten yet? No? Okay. All right. Let's just proceed with my topic. So for me, it's going to be the fork server. As KB has shown us, the smart contract development cycle. Who here are front-end or back-end developers or even project managers? Anyone? Developers? Oh, okay. Yeah, I see a few of them here. Now, you may be asking, while the smart contract team is making their contracts, having it tested, and having it audited, nothing's on the mainnet yet. What are the other devs supposed to do while waiting? So that's where the forgot to plug in. Okay, that's where the common problems come in. So smart contract development is a long and time-consuming process due to the rigorous testing and audits. Because yeah, there's millions of dollars on the line. We can't fail, and if we do fail, it's pretty major, expensive, and we'll have to redeploy another set. The actual smart contracts are only deployed at the tail end of development. So this is after all the audits have been done. We've got all the certificates proving that our contracts don't steal money or have any flaws in them or security issues. So the front-end and back-end developers can only rely on mock data to drive their applications while the smart contracts are not yet deployed. So how can you design your application, your website, your back-end services if there's nothing to interact with on the mainnet? There's also the option of testing on testnets, but that has a lot of drawbacks, such as the need to secure assets and ETH, like Gurley. And when your smart contracts depend on other mainnet contracts, using testnets can't be an option at all. So especially if you rely on popular ones such as Compound or Uniswap, there's no contract on the testnet, or even if they are, they're not updated or they don't behave the way we expect them. So the solution I'm proposing is, how about running your own personalized blockchain node with Anvil? So as you can remember, Anvil is one of the tools that KB discussed in the toolset of Foundry. So here, we're able to simulate the entirety of mainnet and all of its deployed contracts, manipulate the blockchain to meet our development needs, and we'll be able to even deploy contracts and hook up our services to work with them. So anyone here familiar with the concept of forking? Anyone? Yes, Mike. Yeah. Yes, exactly. And now we can do that on our local using Anvil. So for the other people here, imagine this is the blockchain. It's composed of the blocks, which are round for some reason, but these represent blocks. What we're doing on our local now is we're creating a separate branch of the blockchain. So we have our own blockchain running on our local, and we also get the previous blocks. That means we get access to all the tokens, all the events. The entire history of the blockchain is accessible on your local with this technology. So I'll proceed with the live demo now. All right. Okay. So first, I'll be showing you one of the products that we have developed here in-house in Oostenvoort. So this is Lever Finance. It's a platform where you can trade, you can lend. So basically, we'll be using the lend portion of the application. So here, what you do is you lend assets for other traders to use So as you lend, you also earn some extra income because the more your asset is used in trading, the more utilization goes up, you get more and more benefits. So here, we're about to do some testing here on the mainnet. So, okay, let's start. Oh, I don't have any money. Yeah, okay, that's gonna be hard. I don't have any USDC, USDT, Bitcoin, or Ethereum. So, yeah, how are we supposed to test this? So, right now, on my local, I have the fork server here running. So, we just need to connect our MetaMask to the local host. So this is it, the local host, and oh, all right. So also we'll need, right now this site doesn't support using your local host, but we do have one available here. Let's just load it. Okay. Just a quick switch here. Yeah. So let's just connect here to our local using MetaMask, and all right. So, okay, I just started the server, so the money's not there yet. What we do have is I created a dashboard for the fork server. So here we can access all the controls we need to manipulate the blockchain. So just click here on the MetaMask, and then yeah. So let's say, wait a minute. Let's just do a quick reset, because MetaMask doesn't like it when we're working on forks. Okay, it's weird. Okay, 137. Yeah, okay, we're good. Okay, so let's say I need some USDT. I'll just click here on fund, and oh yeah, we'll have to go here. So basically, I just need an address that anyone that holds USDT. So let's just copy one of the addresses here. So this is a holder of, how much is that? A billion or something USDT. We'll just need it for the example here. Okay, and then we just run fund.
So Mike,
yes.
Basically you're making a copy of the blockchain and you're taking someone's funds.
No,
Whatever you want.
No, I'm not taking their funds. I'm just using it as a reference because I'm actually going over the storage in the contracts. So I just need to know who is holding USDT at this moment. And I'm actually going to have more than him after I reset my MetaMask.
So, at this point, you can be disconnected from the internet.
No, I still yes, I still need the live connection since I don't have the Ethereum copy on my local entirely. I only have like a range of blocks that I have knowledge of. So if I need access to like older blocks, like a week ago, I do need internet access for it to work. Yes, it only copies like shallowly. Um, no, yeah, because we need to fork from the live mainnet, so we can't entirely copy it like a file. So, okay. Now I have, how much is that? 2,833 trillion USDT. Okay, that should be more than enough for testing, right? Okay, let's just head over here to the lend portion. Yeah. No, this is running on one of our servers right now. Yes. So, okay, yeah, 2 trillion USDT. We can now do some testing. Might as well send myself some more ETH as well. And yeah, let's just reset our MetaMask right now. Yeah. Yeah, we can actually bail out SVB if needed. Okay. All right, the ETH's here, and I have, how much is that? $8 billion? Million? Yeah, that's fun. Okay. So again, the front end doesn't know that we're using a fork, so it still behaves as if we're using the mainnet. So here I'm doing a USDT, so I'm even fooling MetaMask right now. And let's try to deposit, like, let's say, yeah, $1 million. And here we go. And then let's go back, and yeah, I already have here 1 million, but yeah, it's fake money and the earnings don't mean anything. Okay, so other features, the other one that I like is also state management. So state management, as KB discussed earlier, we're able to take snapshots of the blockchain. We're able to get a copy or like a representation of the blockchain during a specific time with specific modifications. So right now, yeah, I just wanted to test because I wanted to actually put more USDC, Bitcoin, wrap ETH in there. But yeah, it's gonna take a lot of time to do that. So good thing I already prepared it earlier. So we're just gonna load that state. Yes, it's like I'm loading a game right now. So this is what 8 a.m. Yesterday. Then we just do a reset on MetaMask. This is, by the way, to reset the nonce, since my account on the fork server does not match the nonce on the MetaMask that I have. Just do a reset, and then once we refresh, hopefully the load game finally worked. Yeah, maybe not. And there we go. So, as you can see here, this is the scenario I set up yesterday, and I was able to load it up today. So with this technology, you can share the state of the blockchain to any one of your coworkers, to your clients. So simulation of scenarios can be easily done and shared between work. Then the remaining features here are, yeah, we're able to manually mine blocks. So on Ethereum, it's 13 seconds for a block to be mined. But here we can just mine 500 real quick. And yeah, that's 500 blocks mined instantly. And we can also increase the time. So this may be useful for your contract depends on days passing, such as the interest growing or the like what do you call that? The liquidation happening. Like if you want your numbers to go up during time, you can just use this feature. So this will increase the timestamp, and yeah. So there's more you can do with this. So what I've shown you is just the basic features. So the good thing here is we publish this project on Blockdevs Asia for free for everyone to use. So this is open source. So yeah, just head on over to Blockdevs Asia, and yeah, you can start forking your own network today. Thank you. Okay, I will be taking questions as well. Yeah. Any questions? Yes, for ETH and layer 1 and layer 2, such as BSC, Polygon, Avalanche. Yes, and EVM. Yes.
Were you able to address issues that double spending
Double spending.
or blockchain in Ethereum?
Is this like a?
Yeah, I think double spending actually that's more of an attack on the
Ah.
network itself, right? How would you address today? I think Ethereum changed a lot in the last 5 years. So Ethereum is no more proof of work. It's now proof of stake.
Oh, yeah.
So yeah, for double spending for that to happen on Ethereum, yeah, it's different. And it's very unlikely. So yeah. So in this context, yeah, the data is not there. Or, yeah, you could know.
Yeah,
No.
but actually that's a good point.
Yeah.
So that can also be a use case for this product. since you can emulate attacks on the fork server. So if you have like a script and you want to empty out like a bank or something, you can try it out on the fork first before doing it on live. So yes, so that's another use case.
That's actually that's a good point. The double spend from the network, yeah, this is in the past, not very relevant right now. But yeah, this is a financial system, and we programmed it to the best of our ability. And it has been audited several times, but there may be a flaw in there that allows someone to withdraw funds twice, right? So yeah, those flaws, I don't think they're there. But this system is a way to test that.
Yeah.
Yes, to test all kinds of attacks without spending too much money, without spending any money.
No money.
So you're saying that you can choose when you want a copy of Ethereum during that time that it happens,
Yes.
so you can actually watch before your eyes.
Yeah.
Yeah.
Again, the same, so if you want to start making more, that thing that happens.
Well,
Exactly.
Hacks.
Yes.
Theoretically, let's say there was a hack on at this specific block, this day, this time. You could take a fork of the moment right before the attack,
Yes.
and then look at how the attack was executed, and then do it yourself to learn from it, to figure out what was happening.
Yeah.
As well as you know that block, so have
Block number.
yeah.
Yeah.
And then you can make a safety or like
Hmm.
safe.
Yeah. So hack it. Try it again. Yeah.
So it's useful for security as well.
All right. More questions? None? All right. Thank you guys for listening. And yeah, Michael Francisco.
Alright, so conclude
Taas kasi ng volume ni KB kanina. So imagine mo kung naka-on yung speaker kanina. Sabog tayo.
Blockchain's newest
Yes.
Microsoft SQL Server in the cloud.
Oh, the last thing I read is that there's a cryptocurrency wallet in Edge, in the browser. But you're saying it's also in SQL Server?
Microsoft SQL. They just implemented smart contracts in the latest version of SQL on the cloud.
Interesting.
They have implemented using an external server for smart contracts.
Okay. Interesting.
We
Yeah.
discussed that in Microsoft last week, 2 weeks ago.
So that's new.
Interesting.
Yeah, because now I'm a bit puzzled because the news was Instagram and a few of the others, they're actually dropping the NFT support. But now Microsoft is adding cryptocurrency to their browser and to the database server. Yeah. Now Microsoft is doing interesting things. Yeah. I wasn't aware. Yeah, who knows?
It's good news.
Yeah. Yeah. Anyone else? No more? Alright, so this is a meetup. I think after this, we just, talk about stuff. I think the last official thing is next meetup, right, Mike?
Yeah.
So 2 things. Next meetup is on April 25th. Or do you want to take the word?
Yeah, I want me to.
That's your meetup.
Yeah, that's mine. Hey guys, my name is Mike Reyes. I am the community manager and treasurer of Blockdevs, and I'll be kind of heading up the ecosystem meetups because I can't code. So yeah, I know. I don't trust my code. But I got into the space from the economics and philosophical side, and the use case and the real world and how this can actually help us get away from. I won't go down that rabbit hole, but improve our monetary systems and our social systems. So we're going to be doing our next meetup in April 25th. That's a Tuesday at my small bar in Makati. So little different setup. We don't have a topic yet, but with the advent of the current banking crisis that's happening in the U.S., we're probably going to be talking a little bit about that and how what we're doing here is going to be the solution to all of these things. So please, hopefully you guys can all come there. We're gonna have some pizzas, some drinks, and have a good time just kind of chatting and getting to know each other and developing a community. Second thing is we're looking for some people in the community that want to kind of be admins for our, we want to start a Discord server. We want to redo our Telegram chat rooms and stuff like that, and we need just some support because we're both working full time, so we need people who want to kind of help and want to step up to that kind of admin position within the community. So if you guys are interested, reach out to me or Casper, and we'll get you guys sorted out. We're excited. We're kind of rebooting Blockdevs this year, growing, getting warmer, as Casper said. And thank you guys for being here. Appreciate it.
Yeah, thanks. Yeah. So, what's next?
Yeah. Open discussion.
Open discussion, yeah. I mean, yeah, it's an open format. I believe we have some snacks coming up later. So feel free to stick around. Yeah, we can talk about stuff. It's a meetup. So we didn't, I told everybody, like, don't treat this as like an investor presentation or anything. We're just exchanging information. So, yeah.
Cool.
Thanks for coming.
Great.
And stick around. Thanks, everyone.
Awesome. Thank you.
Oh yeah, so I forget a whole bunch of stuff. So we are experimenting also with some things in ETH Denver, one of the biggest Ethereum conferences. They pass out their attendance certificates in a different way. There's a weird name, it's called POAP. Mike set up, we set up our own. So we have a computer here with a QR code. This is the future of attendance certificates. So if you want to try it out, if you want to get a unique proof that you were here today, go ahead, try it out. So this is, we have to eat our own dog food, right? So this is Ethereum technology used not for sending money, but for proving you were there. And I believe Elon Musk or whatever, people are using it to prove like, oh, I was with this famous person. So it's not just to prove that you were at the place, but also with someone. And it's very experimental. It's interesting.
Of course, that's an immutable evidence that you're there.
Yeah, exactly. So give it a try. Or put the laptop
over there beside
over
the
there.
snacks. We have our snacks already.
Alright. Yeah. And then finally, Marianne, Kim, Thea, Lee, thank you so much for being here early, preparing everything. It's great. Thank you. That is not named yet. It's the Gnosis chain. Yeah. So feel free to try it, and if you want to complain about it or ask questions about it, this is the place, I guess. Oh yeah, we have a yeah, that's a classic. The 10 rules. Okay. I think this one is yeah, it's yeah, this is yeah. So, well, that's a very good question, guys. Stable points are falling over. And yeah, that's the first question. Stable points are there. I showed this map. we are basically working on it. Building I think we did
Okay na to. Mag... Mag-photo lang dito. Photo up tayo. Pwede ba tanggalin to? Okay, nag-record pa naman. Dito sana i-picture.